Here we go, guys. We're on 3A.3, part B, sine and cosine function values, okay? We're going to just reiterate the importance of it. Notice how it may feel repetitive. It's because this is the stuff you have to have memorized, especially if you're going into AP calculus, or if you plan on doing calculus or physics in college. These are things that they are considered you need to know entering into those classes, okay? And so, yes, it may feel repetitive, but it's for a reason so that it sticks in your brain, okay? So first, we're going to talk about trigonometric functions of an angle. So when you're looking at any angle on a unit circle, any angle on a plane, you can find its sine, cosine, and tangent value based on three things. It's change in its x coordinate, the change in the y coordinate, and its radius, okay? By change, we're talking about how far away is that point from the origin, okay? So notice here, we have the origin, and you've gone a certain distance out. That's called your radius. So straight from here, that is your radius, right? Your R. Now, from the origin, how far left or right have you gone, and how far up and down have you gone? Okay, that's going to be your X and Y value. Those relationships have a ratio that we follow. So we're going to use this angle as our point to learn. When I do this, what did I just create? A right triangle, right? I created a right triangle that has gone a distance of X and a distance of Y, and has a hypotenuse of R, right? So if I wanted to find the sine of the angle that's created by this, how would I find sine? Well, what's our rule for sine back in geometry? It would be y over r, but in geometry, it was opposite over hypotenuse, which is y becomes y over r. So when you're drawing it on a coordinate plane, it's going to be y over r. Remember, we had an argument with the printer. We just going to take what it gave us, okay? Our cosine theta. Cosine is adjacent over hypotenuse. What's adjacent to our angle? What's our hypotenuse? R. Tangent is opposite over adjacent. What's our opposite? And our adjacent is X. So these are the rules that we follow, okay? So when we follow these rules, we then can establish some other rules. Our Y equals R times our sine theta. And why do I know this? Because if I need to get Y by itself, what would I do to R? Multiply. Does that make sense? So with that same thought in mind, what would X equal? R times cosine, not cosine. I don't know what I was writing. Cosine theta. And then what does this represent? What does your change in Y over your change in X represent? It is your slope. It is the slope of it. It is the slope of your radius. Something that never changed, right? Change in Y and change in X has always been slope, Algebra 101. Okay? The relationship between all of these are R equals the square root of X squared plus Y squared. Can someone tell me why? Pythagorean theorem. Look here, guys. I don't know what I'm saying anymore. I didn't go to bed till 4 o'clock. So we had been asleep for an hour and a half. I did not wake up at 30.
No, but I'm just saying, like, that's like,
And that's crazy. Yeah. Tell me about it. All right. So how do we feel so far? So what this means is that as long as I am given enough information, I can pretty much find all of the things I need to know about an angle or its sine, cosine, and tangent on a coordinate plane. Got it? All right, let's see how it goes. So up first, it says given an angle of theta equals 4 pi thirds in standard position. So this is going to be standard position, 4 pi thirds. okay? And we know that it has a radius of 5. So our radius is 5. And find the coordinates P equals X comma Y of the angle. Well, can we find our coordinates? Yes, because what did we learn X and Y equal? Did we not find how to find our slope? I mean, our quarter pair? Do we see this? It's just our sine theta. It says to find the ordered pair. X and Y is our ordered pair.
We know theta.
We know our theta. So our theta equals 4 pi 3. We know our R equals 5. To find our X equals R cosine theta, and Y equals R sine theta. Because this is still this would come out to tell you how far left you would go and how much down you would go. That's what your X and Y is describing. Even though, yeah, it's never going to actually be a real triangle, by the way. Yeah. Yeah, it's never going to be an actual real triangle.
My first thought would be like, oh, we just use.
The triangle is the way for you to learn how to establish the rules. That's how we ended up with what X equals and what Y equals. All right, can I find my X and Y now? All right, so plugging in what I know. R is 5. Oh, of course, my pen had to be extra. 5 cosine of 4 pi over 3. And Y is 5 sine 4 pi over 3. I don't know. I would assume that if they give it to you in radians, they want you to keep it in radians. So understanding that you're at 240 would be my guess. All right, so X equals 5 times what? What is cosine of 4 pi over 3? What's cosine of, no, unit circle knowledge. Unit circle knowledge, no calculator.
It's 1 over 2. Negative 1 over 2.
There we go. It's negative 1 over 2.
Like I know the first one was negative.
So that's going to give me negative 5 halves. Why? 5 times the sine of 4 pi over 3. So what is sine of 4 pi over 3? There we go. So we get negative 5 square root of 3 over 2. So my ordered pair, my point is going to be negative 5 halves, comma, negative 5 square root of 3 over 2.
We need to be able to like see the unit circle in our mind like that. Because like I can do it easily, like if I'm writing it out on paper. But like
So they're not going to give it to you on the test.
well, yeah. Well, I'm saying like
I mean, you could draw it out quickly if you want to use your time. Yeah, if you want to use your time to draw it out quickly, draw it out.
because I have like seeing it in my mind is like hard. But I can easily like by memory write it.
Yeah. I just go by the triangles.
Just like that quadrant. Like if I just wrote that quadrant.
Yeah. What you write is your helping tool on your test is up to you.
That one quadrant.
If you just have quadrant 1, in my opinion,
Yeah.
you can do everything else.
But like I would just draw a quadrant.
Yep. All right. What are our questions, comments, concerns? Move on. Okay. I was just checking. I didn't want to be like, All right, moving on. So now it says if theta terminates in quadrant 2, that means that our angle's in quadrant 2. In quadrant 2, what's the only positives? The y. So therefore, which trig value is positive? Sine. All students, right? Where we're at the S. Okay. Yes. If theta terminates in quadrant 2, cosine theta equals negative 1/3. Find the value of sine theta. Okay. So this is where it comes into play of us knowing our rules. So when we wrote that x squared plus y squared. Wait. Yeah. Equals r squared, right? Yeah, but I'm writing it out as Pythagorean. We wouldn't, if we were solving for r, then yes. Okay, well, we also wrote a ratio for cosine. We wrote that cosine equals what in terms of x's, y's, and r? X over r. So if cosine theta is x over r, and they gave me a fraction, we know that x is -1 and r is 3. Do we see that? This is my x. This is my r. Your radius is distance, and distance is always positive, okay? Your radius is distance, and distance is always positive. In order to find sine, what do I need? My y, right? So this is why we weren't getting r by itself. We needed to get what by itself? Y by itself. So in order to get y by itself, that's going to be y equals the square root of r squared minus x squared. Agreed? We're all okay with that? So now can I solve for my y? So y equals the square root of, what's my r? 3 squared minus, what's my x? -1 squared. I don't know why my pen keeps doing these things. It literally only does it in pre-cal. So it's a strange situation. So y equals the square root of 9 minus 1, which equals the square root of 8, which equals 2 square root of 2. Why does 8 equal? Square root of 8 equals 2 square root of 2. Those are the prime factors of it. There we go. Anytime that this has a perfect square that is a factor of it, they will probably count off points if you do not completely factor it. All right, so now we have our y value. Can I establish what sine is? Yes, because sine is what again? Sine is our y over our r. Do we have our y? Our y is 2 square root of 2. What is our r? 3. So sine equals 2 square root of 2 over 3. No, there's no reference, no handout, no nothing. I checked.
There's no reference.
On some problems, they may give you formulas, but there's no like handout to give you. Yeah, not like STAR. Otherwise, we've been using it, or I would have had it in your notebook this entire time, but they didn't give us a reference sheet that you would be able to utilize.
Any other math APs?
I didn't have an AP Cal. I didn't have one in AP Cal.
One of them was the one of them was
Does it? He keeps giving it the star reference sheet.
it was the bell
Yeah. Oh, the bell curve on there.
I thought that was
and all
the
like
star one.
p-values.
Yeah. So much of pre-cal is assumed and memorized because you can prove it from previous knowledge that I guess they assume you'll always have your algebra skills to fall back on.
Like, I don't know, most tests give you like geometry though.
Yeah.
They give you like geometry.
Yeah, that's the ones give you a piece.
Yeah.
And then those ones give you all.
That's what I'm saying. On certain problems, if it's needed, I'm to my understanding, they'll give you that. Like they'll tell you if volume of a cylinder equals 4 pi thirds or times h.
Is that true?
No, I think that's sphere. I didn't mean to say cylinder, but you know what I meant.
I don't know what
Yeah.
the volume
Okay,
is.
I think
Sphere
it
is
was pi.
You always just use pi. Mhm. Never use 3.14.
No, I'm talking about like in our answer to be.
It'll tell you in terms of pi. So if it says in terms of pi, then you leave. If it says approximate, then you put
Or
pi.
you can always-
You can put both and just convert, but all great questions. But I will double check. I didn't
You
see a
said that
reference.
your teachers are gonna have us do 3 decimals on the test?
Yes, so, and I'm gonna verify, but with Mr. Smith in calculus, you truncate. So you don't even round up, you just, whatever the third decimal is, you just truncate. You just chop off the rest. And so I'm going to check in our little AP
It's like
pre-calc.
same thing during day.
It's just like truncating, like, okay, 3 decimal places, wherever that ends, that's your answer. And I'm gonna double check, but I'm pretty sure that if that's how they grade it in AP Cal, But it's gonna be the same for pre-calc, just truncating at 3 decimals. Yeah. So. All right, here we go. Find all values of theta between 0 and 2 pi where cosine theta equals 0. Okay, so if I'm looking for when cosine theta equals 0, cosine theta means I'm looking for what? Your x, right? If I'm looking for cosine theta, I'm looking for x. So if I'm looking for x and I need x to equal 0, what values? Where? There we go. And it says in terms of radians, so we know that theta can equal pi over 2 or 3 pi over 2. And it gave me a window from 0 to 2 pi. So that's why it would only be these two. Because remember, you can go around and around in a circle. But it gave me limitations on what that angle would be. Okay? So being comfortable reading and interpreting what things are equal. So if I asked you vice versa, where does sine theta equal 0? Where would you tell me? Pi. And what else? 2 pi. It would have to include 2 pi. Oh, it says less than. You're right. It couldn't be 2 pi. It could because it says equal to. It would just be pi and 0. If you pay attention to your restrictions, your domain restrictions. All right. So being able to use that. So that's how the quadrantals would work. All right. So now it says your tan theta equals 4/3 and cosine theta is less than 0. Excuse me. And sine theta, find sine theta and cosine theta. The coordinates where the terminal side of the intersects is circle. Okay. All right. So first off, we're going to determine what quadrant does this angle lie in. Okay. So thinking about tan theta, tan is only positive in what quadrants? 1 and 3. It's positive in 1 and 3. So my angle can't be here and my angle cannot be there. Does that make sense? The next thing it tells you is that cosine is less than 0. If cosine is less than 0, what does that mean it is? X is negative. So therefore it's not in quadrant 1. It says it in the problem. It says cosine theta is less than 0. What kind of numbers are less than 0? Yeah. So we're in quadrant 3. In quadrant 3, we're going to now apply what tan theta means. So tan theta equals 4/3, which means that's your y over your x. So it goes 3 out and 4 down. And that is my radius. So we went 3 to the left and we went 4 down. What would r have to be here? 5. This is a Pythagorean triple, right? It's going to always be 3, 4, 5. Anytime you have 3 and 4, you automatically have 5. If you forget, what can you always do? Pythagorean theorem, okay? So it says for us to find our sine and our cosine. Can we happily find our sine and our cosine? And we can, and our ordered pair. So P equals what? P equals -3, comma, -4. What is our cosine? Your point, the point where it lies. Cosine is -3 what? It's your x over your r. So it's -3 over 5. And our sine theta is -4 over 5. And that's because it's y over r. Questions? Okay, last problem is we are going to need a calculator, but we just need like a basic typing, like scientific. If you have your phone, just turn it sideways. You should be able to access the sine button, cosine button. If not, and you have your computer, just open your computer. This is a real world example. Anytime you have a real world example, it's going to most likely tell you to approximate, which means it's going to ask for a decimal value, okay? So it says a machine's shop needs to drill through a steel plate at point P. Calculate the actual measurement for the placement of the hole, then use your calculator to approximate the location of the hole by the drill, okay? So it tells me my radius is what? 14. It tells me that my theta equals 25. So can I find X and Y with radius and theta? Yes, because X equals what? R cosine. And Y equals R sine theta. And I have everything I need to plug in and solve, right? So I'm going to plug in, and we have 14 cosine of 25. And we have 14 sine of 25. The key thing is when you're using your calculator, please make sure it's in degree mode. If I'm given degree mode, I have to make sure that my calculator is also in degree mode. So I'm going to,
You go to the mode of the old.
it's the same, it's all mode. You're gonna go to mode regardless and switch from radians to degrees. All right, Sylvie. Sylvie hasn't been turned on in a while. We haven't used her in a minute. So I'm gonna go to mode, and you see where it says radian, I need to switch it to degree. Now, if you didn't want to make that switch, what could you do to 25? You could convert it and multiply by what? Pi over 180. Perfect. So smart. So we have 14 cosine of 25. Enter, enter, enter. And we have 14 sine of 25. 3. Yeah, and we're practicing with truncating. So we just stop it at the third. So for our cosine, our X value, we get 12.688. And then for our sine, we get and that is where the drill would have to go to get the precise measurement. And that is a real thing that takes place. I mean, if you program the machines, you will. I don't know. I don't know what your dreams are. You could want to program machines.